Welcome back to HPE Discover 2021, the virtual version. My name is Dave Vellante and you're watching theCUBE, and we're here with Guido Appenzeller, who's the CTO of the Data Platforms Group at Intel. Guido, welcome to theCUBE, come on in.
Thanks, Dave, I appreciate it. It's great to be here today.
So I'm interested in your role at the company. Let's talk about that. You're brand new. Tell us a little bit about your background. What attracted you to Intel and what's your role here?
Yeah, so I'm, I grew up in the startup ecosystem of Silicon Valley, came for my PhD and never left. And, built software companies, worked at VMware for a little bit. And I think my initial reaction when the Intel recruiter called me was like, hey, you got the wrong phone number, right? I'm a software guy. That's probably not who you're looking for. And, but we had a good conversation. I think at Intel, there's a realization that you need to look at what Intel builds more as this overall system. From an overall systems perspective, right? That the software stack and then the hardware components are getting more and more intricately linked, and you need the software to basically bridge across the different hardware components that Intel is building. So I'm here now as the CTO for the Data Platforms Group, so that builds the data center products here at Intel, and it's a really exciting job. Right? These are exciting times at Intel. With Pat, got a fantastic. CEO at the helm. I worked with him before at VMware, so a lot of things to do, but I think a very exciting future.
Well, I mean, the data center is the wheelhouse of Intel. I mean, of course, your ascendancy was a function of the PCs and the great volume and how you changed that industry, but really data centers is where it, I mean, I remember the days people say, Intel will never be in the data center, it's just a toy, and of course, you're a dominant player there now. So your initial focus here is really defining the vision, and I'd be interested in your thoughts on the future, what the data center looks like in the future, where you see Intel playing a role. What are you seeing as the big trends there? Pat Gelsinger talks about the waves. He says if you don't ride the waves, you're going to end up being driftwood. So what are the waves you're driving? What's different about the data center of the future?
That's right. You want to surf the waves, right? That's the way to do it. So look, I like to look at this in terms of major macro trends, right? And I think that the biggest thing that's happening in the market right now is the cloud revolution, right? And I think we're halfway through or something like that. And this transition from the classic, client server type model, that we're with enterprises running their own data centers to more of a cloud model where something is run by hyperscale operators, or it may be run by an enterprise themselves, or it may sit at the edge. So there's a variety of different models. But the provisioning models have changed, right? It's much more of a turnkey type service. And when we started out on this journey, I think we built data centers the same way that we built them before. Although the way to deliver IT had really changed, right? It's gone to more of a service model. And we're really now starting to see the hardware diverge, right? The actual silicon that we need to build in order to address these use cases diverge. And so I think one of the things that is kind of most interesting for me is really to think through how does Intel in the future build silicon that's built for clouds, like on-prem clouds, edge clouds, hyperscale clouds, but basically built for these new use cases that have emerged.
So just a kind of a quick aside, I mean, to me, the definition of cloud is changing, it's evolving. It used to be this set of remote services in a hyperscale data center. It's now, that experience is coming on-prem, it's connecting across clouds, it's moving out to the edge, it's supporting, all kinds of different workloads. How do you see that evolving cloud?
Yeah, there's, the biggest difference to me is that a cloud starts with this idea that the infrastructure operator and the tenant are separate. Right, and that actually has major architectural implications. I mean, just to, I'm not sure this is a perfect analogy, but if I build a single family home, right, where everything is owned by one party, I want to be able to walk from the kitchen to the living room pretty quickly, if that makes sense, right? So, in my house here, it's actually an open kitchen, right? It's the same room, essentially. If you're building a hotel where your primary goal is to have guests, you pick a completely different architecture, right? The kitchen from your restaurants where the cooks are busy preparing the food, and the dining room where the guests are sitting, they're separate, right? I mean, the hotel staff has a dedicated place to work, and the guests have a dedicated places to mingle, but they don't overlap typically. I think it's the same thing with architecture in the clouds, right? That's initially the assumption was it's all one thing, and now suddenly we're starting to see, like a much cleaner separation of these different areas. I think a second major influence is that the type of workloads we're seeing is just evolving incredibly quickly, right? I mean, 10 years ago, things were mostly monolithic. Today, most new workloads are microservice based, and that has a huge impact in where CPU cycles are spent, where we need to put in accelerators, how we build silicon for that. To give you an idea, I mean, there's some really good research out of Google and Facebook where they run numbers. And for example, if you just take a standard system and you run a microservice-based, an application written in a microservice-based architecture, you can spend anywhere from, I want to say 25, in some cases over 80% of your CPU cycles just on overhead, right? And just on, marshaling, demarshaling the protocols and, the encryption and decryption of the packets and your service mesh that sits in between. All these things, right, create a huge amount of overhead. So for us, right, if 80% go into these overhead functions, really our focus only needs to be on how do we enable that kind of infrastructure.
Yeah, so let's talk a little bit more about workloads if we can. I mean, the overhead, there's also sort of, as the data center becomes software defined, thanks to your good work at VMware, there's a lot of cores that are supporting that software defined data center. And then
that's exactly right, yeah.
And as well, you mentioned microservices, container-based applications, but as well, AI is coming into play, and what it is, AI is just kind of amorphous, but it's really data-oriented workloads versus kind of general purpose ERP and finance and HCM. So those workloads are exploding, and then we can maybe talk about the edge. How are you seeing the workload mix shift, and how is Intel playing there?
Look, I think the trend you're talking about is definitely right? We're getting more and more data-centric. Shifting the data around becomes a larger and larger part of the overall workload in the data center. AI is getting a ton of attention, right? It's look, if I talk to the most operators, AI is still an emerging category, right? I mean, we're seeing, I'd say 5, maybe 10% of workloads being AI. It's growing. They're very high value workloads, right? And they're very challenging workloads. But it's still a smaller part of the overall mix. Now, edge is big, right? And edge is two things. It's big and it's complicated, because the way I think about edge is it's not just one homogeneous market. It's really a collection of separate sub-markets, right? It's very heterogeneous. It runs on a variety of different hardware, right? Edge can be everything from a little server that's fanless, that's strapped to a telephone pole with an antenna on top, to create a microcell, or it can be something that's running inside a car, right? I mean, a modern car has a small little data center inside. It can be something that runs on an industrial factory floor, right? The network operators, there's a pretty broad range of verticals that all look slightly different in their requirements. And, and it's, I think it's really interesting, right? It's one of those areas that really creates opportunities for vendors like HPE, right? To really shine and address this heterogeneity with a broad range of solutions. Very excited to work together with them in that space.
Yeah, so I'm glad you brought HPE into the discussion, because we're here at HPE Discover. I want to connect them. But so when I think about HPE's strategy, I see a couple of opportunities for them. I mean, obviously, Intel is going to play in every part of the edge, the data center, the near edge, and the far edge. And I think HPE does as well with Aruba. Aruba is going to go to the far edge. I'm not sure at this point anyway. It's not unclear to me how far HPE's traditional server business goes to the inside of automobiles. We'll see. But it certainly will be at the, let's call it the near edge as a consolidation point, et cetera. And look, the edge can be a racetrack. It could be a retail store. I mean, it could be defined in so many ways. Where does it make sense to process the data? But so my question is, what's the role of the data center in this world of edge? How do you see it?
Yeah, look, I think in a sense, what the cloud revolution is doing is that it's showing us it leads to polarization of a classic data into edge and cloud, if that makes sense, right? It's splitting, right? Before, this was all mingled a little bit together. If my data center is my basement anyways, what's edge, what's data center? It's the same thing, right? The moment I'm moving some workloads in the clouds and I don't even know where they're running anymore, then some other workloads that have to have a certain sense of locality, I need to keep closely, right? And there's some workloads you just can't move into the cloud, right? I mean, there's if I'm generating a large amount of video data that I have to process, it's financially completely unattractive to shift all of that to a central location. I want to do this locally, right? And will I ever connect my smoke detector with my sprinkler system via the cloud? No, I won't, right? It's just for if things go bad, right? That may not work anymore. So I need something that does this locally. So I think there's many reasons, why you want to keep something on premises. And I think it's a growing market, right? It's very exciting. We're doing some very good stuff with friends at HPE. They have the ProLiant DL110 Gen 10 Plus server with our latest third generation Xeons in them. The Open RAN, which is the radio access network for in the telco space. HPE Edgeline servers, also a third generation Xeon. So there's some really, really nice products there that I think can really help addressing enterprises, carriers, a number of different organizations, these edge use cases.
Can you explain, you mentioned Open RAN, vRAN, should we essentially think of that as kind of the software-defined telco?
Yeah, exactly. It's software-defined cellular, right? I mean, I learned a lot about that over the recent months. When I was taking these classes at Stanford, these things were still done in analog, right? That basically a radio signal would be processed in an analog way and digested. And today, typically, the radio signal is immediately digitized, and all the processing of the radio signal happens digitally, and it happens on servers, right? Some of them HPE servers. And it's a really interesting use case where we're basically now able to do something in a much more efficient way by moving it to a digital, more modern platform. And it turns out you can actually then virtualize these servers and run a number of different cells inside the same server. Right? And it's really complicated because you have to have fantastic real-time guarantees, very sophisticated software stack. But it's a really fascinating use case.
A lot of times we have these debates, and it's maybe somewhat academic, but I'd love to get your thoughts on it. The debate is about, okay, how much data that is processed and inferred at the edge is actually going to come back to the cloud. Most of the data is going to stay at the edge. A lot of it's not even going to be persisted. And the counter to that is, so that's sort of the negative for the data center, but the counter to that is there's going to be so much data. Even a small percentage of all the data that we're going to create is going to create so much more data, back in the cloud, back in the data center. What's your take on that?
Look, I think there's different applications that are easier to do in certain places, right? I mean, going to a large cloud has a couple of advantages. You have a very complete software ecosystem around you, lots of different services. You have, if you need very specialized hardware, if I want to run a big learning task where I suddenly need 1,000 machines, right? And then this runs for a couple of days, and then I don't need to do that for another month or two, right? For that is really great. There's on-demand infrastructure, right? Having all this capability up there. At the same time, it costs money to send the data up there, right? If I just look at the hardware cost, it's much cheaper to build it myself, in my own data center or in the edge. So I think we'll see, customers picking and choosing what they want to do where, right? And there's a role for both, right? Absolutely. And so, I think there's certain categories. I mean, at the end of the day, why do I absolutely need to have something at the edge? And there's a couple of, I think, good use cases. I mean, one is, let me actually rephrase a little bit. I think there's three primary reasons, right? One is simply bandwidth, right? Where I'm saying, okay, my video data, like I have 100 4K video cameras, with 60 frames a second feeds. There's no way I'm going to move that into the cloud. It's just, cost prohibitive. Right. I have a hard time even getting a line that allows me to do this, right? There might be latency, right? If I want to reliably react a very short period of time, I can't do that in the cloud, right? I need to do this locally with me. I can't even do this in my data center, right? This has to be very, very closely coupled. And then there's this idea of fate sharing. I think that if I want to make sure that if things go wrong, right, the system is still intact, right? Anything that's sort of an emergency kind of backup, an emergency type procedure, right? If things go wrong, I can't rely on there being a good internet connection. I need to handle things locally, right? That's the smoke detector and the sprinkler system, right? And so for all of these, right, there's good reasons why we need to move things close to the edge, right? So I think there'll be a creative tension between the two, right? But both are huge markets, and I think there's great opportunities for HP ahead to work on these use cases.
Yeah, for sure. Top brand in that compute business. So before we wrap up today, thinking about your role. I mean, part of your role is a trend spotter. Right? You're kind of driving innovation, riding surfing the waves, as you said, skating to the puck,
I have my perfect crystal ball right here. Yeah, go on.
all the cliches, right? Yes, yeah, right. Puts a little pressure on you. But so, what are some of the things that you're overseeing, that you're looking towards in terms of innovation projects, particularly obviously in the data center space? What's really exciting you?
Look, I mean, there's a lot of them, and I pretty much all the the interesting ideas I get from talking to customers, right? You talk to the sophisticated customers, you try to understand the problems that they're trying to solve and that they can't solve right now, and that gives you ideas. And just to pick a couple, right? I mean, one area I'm currently thinking about a lot is how can we build, in a sense, better accelerators for the infrastructure functions, right? So no matter if I run an edge cloud or I run a big public cloud, I want to find ways how I can reduce the amount of CPU cycles I spend on microservice marshaling, demarshaling, service mesh, storage acceleration, and these things like that, right? And so clearly, if this is a large chunk of the overall cycle budget, right, we need to find ways to shrink that, right, to make this more efficient, right? So that I think this basically infrastructure function acceleration. It sounds probably as unsexy as any topic could sound, but I think this is actually a really, really interesting area, and one of the big levers we have right now in the data center.
I would agree, Guido. I think that's actually really exciting because you actually can pick up a lot of the wasted cycles now, and that drops right to the bottom line. But please,
yeah, exactly. And it's kind of funny. I mean, we're still measuring so much with spec end rates of CPUs, right? Performance is like, well. We're measuring the wrong thing, right? If 80% of the cycles of my app are spent in overhead, right, then the speed of the CPU doesn't matter as much, right? It's other functions that I need to learn. Right. So that's one. The second big one is memory is becoming a bigger and bigger issue, right? And it's memory cost, because memory prices, they used to sort of decline at the same rate that our core counts and clock speeds increased. That's no longer the case, right? We've run to some scaling limits there, some physical scaling limits, where memory prices are becoming stagnant, and this is becoming a major pain point for everybody who's building servers, right? So I think we need to find ways how we can leverage memory more efficiently, right? Share memory more efficiently. We have some really cool ideas in that space that we're working on.
Well. Yeah, and Pat, sorry to interrupt, but Pat hinted to that in your big announcement. I mean, you talk about system on package, I think is what he used, to talk about what I call disaggregated memory and better sharing of that memory resource. And I mean, that it seems to be a clear benefit of value creation for the industry.
Exactly, right. I mean, if this becomes for our customers, this becomes a larger part of their overall cost, right? We want to help them address that issue. And then the third one is, we're seeing more and more data center operators are effectively power limited, right? So we need to reduce the overall power of systems, or maybe to some degree just figure out better ways of cooling these systems. But I think there's a lot of innovation that can be done there, right? To both make these data centers more economical, but also to make them a little more green, right? I mean, today data centers have gotten big enough that if you look at the total amount of energy that we're spending in this world as mankind, right, a chunk of that is going just to data centers, right? And so if we're spending energy at that scale, right, I think we have to start thinking about how can we build data centers that are more energy efficient, allow us to do the same thing with less energy in the future.
Well, thank you for laying those out. I mean, you guys have been long-term partners with HPE and now, of course, HPE. I'm sure Gelsinger's really happy to have you on board, Guido. I would be. And thanks so much for coming on theCUBE.
It was great to be here. Great to be at the HPE show.
And thanks for being with us for HPE Discover 2021, the virtual version. You're watching theCUBE, the leader in digital tech coverage. Be right back.